agenda for the webinar today. What we'll be doing is walking through the benefits of automated code review. So talking about really what the difference is between automated code review and manual code review, what automated code review actually entails and what you can expect to see from it, and then what automated code review actually looks like from a perspective of Codacy, right? From the developers who are using Codacy, as well as from the admins who are administering the tool itself. I'm Matt Kohler, so I'll be hosting the webinar today. And if you guys have any questions, as I said, feel free to pop them into the process there for the questions, and then we'll answer those at the end of the call today. Looks like we'll go ahead and get started. So I think the first question to answer, obviously, is what is code review itself? Beyond just being manual and automated, code review itself is essentially the practice of reviewing code based on a pre-designed set of rules and standards, right? And the basic goals behind this are to make sure that anytime there's a change to your code, it follows a set of standards and guidelines that you want to have across the entire organization. So basically identifying various errors, things that might be security standards, or making sure that you're not introducing some kind of vulnerability into the code itself, following best practices, so code complexity, code duplication, coverage, are we actually setting up this code in a way that is going to last a long time for our team, and be understandable for people who are going to be hired and joining in the future, and then make sure you're maintaining, right? You might have different issues that have crept up over the past, and you want to make sure that you're going back and fixing those as well. And as I mentioned, security issues. So one of the most effective ways, of course, to security is ensuring that those issues are never introduced in the first place, right? So that takes place by being vigilant at the beginning of the code review process and making sure that, okay, we can flag this and we can prevent that from ever being merged in. That way it doesn't run the risk of growing, being duplicated across the code base. And also we don't have that vulnerability from the start. So next thing is really to understand why code review is important, right? So Stripe did a research report a couple years back, and they surveyed 1,000 developers, and they asked them, what does their typical work week look like? And the typical developer responded that they work on average about 41.1 total hours per week. And of that time frame, 13.5 hours is spent on actual technical debt, and 3.8 hours is spent on bad code. So things like refactoring, trying to figure out ways around addressing technical debt, these issues, making sure that we're actually fixing these things that might be hindering our development practice today. And in aggregate, across all the developers in the world, the net impact that has is about $85 billion on global GDP loss. Now, this is just these inefficiencies that are created by bad code. And so what code review allows you to do is be proactive on that. Effectively, what it is it's doing the dishes as you cook, so that you're not running in a situation where later on we have to spend all of this time refactoring this code and fixing code and identifying issues and fixing those vulnerabilities, right? So by doing code review, effectively your pie chart here is going to have more gray and less blue. So now that we understand really what code review is and why it's important, it's also important to understand what those differences are between automated and manual, right? That's the theme of this webinar today. So first is to understand what manual code review is, right? And manual code review process is essentially just reading source code line by line in an attempt to identify potential vulnerabilities, right? Generally, when I talk to different teams, this is done by a peer, or a QA team. So generally what happens is a developer will make a commit or they'll make a pull request. And then when they think they're done, or they've done enough of that, they'll submit that for review. And someone who has the authority to review and to merge will go through and check line by line to make sure this pull request is not having a detrimental impact on the code. And if it is, they'll flag that and they'll send that back to that developer to fix. So there's obviously this kind of feedback loop that takes place there. And they're usually running through a checklist to say, these are the things that are most important for us. These are what we're going to flag. And of course, that feedback can be personal. Anytime that we're sending or receiving feedback on our own work, there's a personal component to it. We all take pride in our jobs. We take pride in the type of work that we're doing. We want to make sure that we're being treated fairly and that there's this consistency across this. And so something to consider anytime you guys are doing code reviews is that there is that personal component to that work, especially from the manual side, right? And those conversations should really focus on how this code is written. Is the code logical? Is it written the most efficiently way it can be done? Is it going to be understandable? Can developers who join years down the road understand what we're trying to accomplish based on this code, or should we annotate that better? And so all of these are components that go into a manual code review. The other option, and it's important to understand that these don't go as strictly alternatives, right? It's important to still have developer conversations with your developers on their code, but you want to do that in the most efficient way possible. And that's in part where automated code review comes into play. So automated code review is the process of reviewing your code without that manual input. And it's, once again, it's checking this against a predefined set of rules. So really the differences between automated code review and manual code review in terms of the net impact to the developer and the company is that time spent reviewing, right? You can imagine if you have thousands of lines of code, every time there's a change, the developer who's tasked with that code review has to go through line by line and identify what those are. And so there's only a certain level of human capacity versus that code volume. The other thing to consider is the core competencies these developers have. You know, multiple teams now are using a variety of different coding languages, and it's a certain expectation to be able to understand, you know, issues in Scala versus Java versus Go, right? And so being able to have an automated code review, make sure that you essentially have a machine which is going to be an expert across all of those different patterns, checking consistently and objectively every single time. The other thing is to understand what the feedback loop looks like for the developer who's submitting that code, right? They're working on this code and then they submit that. Generally, they should be moving on to something else because of the time it's going to take. So then the feedback is going to come back to them if there are issues. And they'll have to get back into that frame of mind as far as what was I working on with this? What is this issue? And, you know, searching Stack Overflow or whatever it might be as far as how to fix it, right? So there's a loss of that efficiency there as well. And it's also prone for human error, right? As we work in a more global economy, teams are distributed more and more often. We'll have consultants or contractors who may be offshore. There's a variety in this code review from a manual perspective, right? A code review that takes place on a Friday afternoon is not always the same standard as a code review that takes place on Monday morning. And so we want to make sure that there's this objective consistency across the entire code base, right? And when we talk about coding culture, oftentimes when teams talk about a negative code culture, they oftentimes cite code review practices. You know, was I treated fairly? Was I being picked on based on some of these minute errors? So things that really want to make sure that you're treating everyone, every code review as the same. Those personal biases and those interpersonal communications can certainly rear their heads during those code reviews, even if you don't intend for them to be. And then lastly is that quality assurance, that human versus machine capacity. Now, as we mentioned, you know, there's a variety of different languages. There's sometimes thousands of different patterns you're checking for. You know, what really can we do to check at scale for these different changes? So automated code review, I understand, is a benefit to the way we'll spend this time for developers. It benefits not only the code quality itself, but also the developers themselves, because they're also getting a more efficient workflow and that type of feedback. So what is the way to accomplish automated code review? And a lot of times that's static analysis. So static analysis is a way to review your code that does not actually execute any code itself. So there's no compilation that takes place. So ways that this actually, you know, is important to flag is what it does not offer. So things like technical debt and avoidance planning, things like understanding which ways are code quality trending, things like complexity and duplication are going to be leading indicators if your code quality and your code standards are trending downwards, right? Security screening. We have so many different stakeholders in the quality of our code today, and one of the primary areas that takes place is in security. And so we want to be able to show a record of not only are we checking for this, but we're also able to prove that, and we're able to prove that those security vulnerabilities don't exist in our code. Duplication and complexity, once again, are those leading indicators. Duplication is one of those primary areas where technical debt tends to grow. It runs the risk just like any other kind of debt. And so we want to make sure that it's not going to take more time for us to fix tomorrow than it does today. And that ties right back to that pie chart we showed earlier from the Stripe research. Coverage integration. You spend so much time configuring and writing these tests for your code, and you have, you know, people who are maintaining your CI servers. What percentage of that code is actually being tested? You want to make sure that we have a finger on that. And of course, compliancy. That once again ties into security metrics. You know, there's so many different standards now for OWASP and even just for individual vendors. You want to be able to prove, once again, this is what we check for, and this is how we remediate whenever we identify that. Another important thing to consider when you're looking at automated code review is actually the education on the best practices. It's one thing for a linter to flag an issue. It's another thing to actually tell the developer what that issue is and how to fix it. You're not just investing on the code quality, but we want to be investing in the developers themselves and their understanding of the work that we expect from them. And also the automatic maintenance of rules. So linters are generally what power the static analysis. And there's so many different linters that you'll see here in a moment. How do we maintain these linters to make sure they're in lockstep with the latest versions of the languages we're using, and making sure that we're not wasting so much time with undifferentiated heavy lifting? We're hiring people to do the work building our project and our code base itself. Spending that time maintaining tools and working on that isn't the most effective use of their time. So sometimes you can be creating another problem trying to solve one itself. So what that looks like really is an example of all these different linters that exist for these languages. And as we've already discussed, there's so many different languages that go into play with these different standards and front ends and back ends that you can see there's a huge variety of the linters that are optional. And some of these will be more security focused, some will be more code style focused, and you really need to have a suite of these in order to get a clear and holistic picture on your code quality. And of course, that comes with maintaining and updating these linters as well. So when you're looking at an automated code review platform, you want something that gives a wide variety so you can get that big picture and get that full standards, but at the same time isn't going to require a bunch of heavy lifting on your part to update and maintain those yourself. Another important thing to consider when deciding on an automated code review platform is how it fits into your ecosystem, right? We certainly understand that these tools are expected to play nice. You're going to have your version control systems like GitHub, or Bitbucket, or GitLab. You're also going to have your CI systems like Jenkins or Circle CI. So these are different solutions, of course, than what you're going to expect from your static analysis tool. The CI tool is going to be able to do a compilation, which will then provide your coverage. How is that going to communicate with the static analysis platform that you have as well? There's also point solutions that are purely coverage related. So things like Clover, CodeCov, and Coveralls would fall in that category. And also you're going to have project management tools that are going to aid in that code review process. So things like Jira. If we do find an issue that's existed for a while, how are we going to flag that and go back and fix it? And so we need to make sure that whenever we're considering a new platform, we understand how it fits in this ecosystem, because if you don't take that step and understand that it is a whole ecosystem itself, you run that risk for inefficiency. And examples of what that inefficiency look like are team members spending their time configuring tools rather than coding themselves, costs being multiplied across multiple tools, of course, the tools not being able to integrate with one another, and what that would require then is developers to fix, change their solutions, being trained on multiple tools, and you're once again creating a problem while trying to solve another. Of course, there's maintenance and overhead that comes with each tool, particularly for the on-premise solutions, and then the developers having to go from one tool to another, right? You wouldn't expect your developer to have to go out of their version control system, see if their CI build failed, right? You want that information in line with their workflow. Same with static analysis. You want to be able to flag those issues right where the developers currently work. And so that's why it's important to use a code review suite, right? And this is what that looks like when you do it properly. What are the actual organizational benefits when we find a tool that fits this ecosystem and we've really planned accordingly to make sure it's going to benefit not only the people who are administering the tool, but also the people who are expected to use it. Anytime you're talking about introducing a quality gate to a developer, there's the potential friction for decreasing their efficiency. So we want to make sure that we're balancing their needs with the needs of the company to meet those standards. So tools like Codacy allow those managers to understand what their issues are today. It's interesting, you talk to so many different teams, you ask them what their code quality is, and it's hard for them to answer that, right? Because they know that they're following best practices, they know that they're expecting their teams to do these peer reviews, but if you're not measuring that in aggregate, how do you know if things are slipping through the cracks? And so you want a tool that's going to allow you to flag, say, this is really what your code quality is today, and here's how it's trending. Of course, you want to also benefit the developers themselves. If we can automate that code review process, being able to flag that automatically allows them to save their time and focus on what you've hired them to do, which is coding. It's what they want to do. Also, that code quality standardization, right? By making sure that we have an objective and consistent check against every single change in that code base, we know that we are properly being standardized. Anytime a developer is going to make this change, it's going to compare that against the thousands of patterns that you may enable, and we'll know that which way that code quality is trending, and you can actually enforce that. With tools like Codacy, if there is a pull request that is introducing too many issues, or it's decreasing coverage, or it has some net negative impact on that code quality, you can actually block that PR. And the important thing is we're not just going to block it, But once again, we're going to show the developer why it's blocked and how to fix it. So not only increasing the confidence you have in the code, but also increasing the expectation for the developers on how to fix it as well. Predictability. Now, as we mentioned before, duplication and complexity are really leading indicators on which way our code quality is trending. Oftentimes, if you're doing a sprint, there's a focus on getting a new feature out as soon as possible. There might be a relaxation in the standards that you have. And if that's the case, we want to understand what the impact that had on our code quality and how we can remediate it in the future. Also, team management. Being able to have a suite that understands how projects compare from team to team, and if there's certain patterns that are occurring more frequently, allows you to be proactive in helping the people who need help and training on the areas that might be more necessary, right? A good example of this is working with a company who was very, very large, had thousands of different projects, and they wanted to open source internally these various projects so other teams could benefit from them as well. But they didn't have an understanding as far as which projects were good examples of that and which ones were bad. And so when you add an automatic code analysis platform for code review, it's going to allow you to grade those projects and say, this is an example that we should use across the company of the code standards we want to have. Whereas you can also identify which projects are going to need additional resources or some help. And lastly, being proactive, right? One of the most effective measures to avoiding that time spent fixing code and refactoring is by making sure that that problem never gets introduced in the first place. So being able to block a PR that's going to be able to create those issues is a way for you to ensure that your code quality is trending the most effective way and not negatively. And the last thing I want to highlight here is also these code review tools aren't just a way for you to flag and prevent problems. It's also a way for you to acknowledge the hard work and the quality work that developers do, right? Oftentimes when developers are working on code, we know that it works or we know that it doesn't, right? But we don't know confidently, is this up to the standards we have? And so if developers are objectively doing quality code that meets your standards and they're fixing issues, it's important to be able to acknowledge that as well. And that's something that should also be considered anytime you're evaluating a tool like this. So next, I want to navigate over to a Codacy demo. The main focus for this is really to show what Codacy looks like in terms of automating that code review process and what you can expect both from the developer's perspective as well as the individuals who are administering the tool themselves. For the demo, I'll go back and forth between two different projects. One is going to be an open source project from some of our users at PayPal. It's a good example of what Codacy looks like at scale when it's been used over time. And another one is going to be a Java demo. So this is a demo account that we have in which I can make changes on, and it's not going to adversely impact anyone. So the first thing you're going to see with Codacy is that anytime you add a project to Codacy, we're going to grade that on a scale of A through F. Once again, this is to allow any individual, technical or not, to understand that this is a project that is a good example of quality code, or if it's a project that requires additional attention, right? Now, the natural question then is, what is that grade based on? And it's based on 4 primary factors: the amount of issues in the code, and those issues can certainly range from something as simple as code style, is this going to be legible to other developers in the future, to things that might be more severe, like security, right? Do we have vulnerabilities that exist in this project today? Complex files, so cyclomatic complexity, the number of different layers we have with this code. If you have a section of code that has 20 different if statements, that could probably be written more efficiently. And it's going to be something we want to flag as an indicator to see if we can improve that code quality there. Again, duplicate code is an area where technical debt tends to grow. It's something where we can identify, like any other kind of debt, if we're trending in the wrong direction. And if so, if it's going to take more time for us to fix tomorrow than it does today. And any solution you're going to be using should give you the option to customize what duplicate code would be, right? In some cases, you might be more strict with that or more lenient. And lastly, code coverage. When you're going to be testing your code, what percentage of that code is actually going to be tested? And all of these different metrics should be actionable. So in this case, we're going to not only show you which files have coverage, but which ones don't have coverage. So you can make sure you can prioritize those in terms of adding that. On the right, we have what we call hotspots. So as your code base grows, as the number of developers who contribute to your code base grow, we want to make sure that we're surfacing at a macro level different trends so that you can act upon it. And it's not going to be falling through the cracks. So a key example of this would be if we notice there's a certain pattern that's reoccurring more frequently, that's an opportunity for you to understand, is this something that we need to do a training with our team on? Is this an issue that people really don't understand and keep reintroducing it? Or is this something that's misconfigured? Is this a standard that we don't want to enforce? And that way you can go ahead and address those there. Logs will allow you to keep a record of any administrators who are removing patterns or ignoring issues. And probably most importantly is the ability to actually manage and understand these pull requests themselves, right? So as we discussed with Codacy, what it allows you to do is establish these standards across these 4 metrics. And then anytime a pull request takes place that's going to have a detrimental impact, say we're introducing too many issues or a decrease in code coverage, we can actually flag that as not being up to standards. And you can even take that a step further by blocking that pull request to prevent that developer from having that negative impact actually go into the code base. So here's what that looks like from the developer's perspective. If I go to the PR, we'll see what the status is. These are all of the open pull requests, who the author is, when it took place, and once again, most importantly, what's the net impact this pull request had on the health of this project. So if I go to this, it'll show me once again, this is not up to standards. And the important thing is it's going to show me why. If a developer is introducing issues, it'll show me how to fix those issues. It'll show me the impact on duplication, coverage, and complexity. And again, the most important step of this is not just to flag the issue itself, but to show the developer what the issue is, approximately how much time it will take to fix it, and how to fix it. This again tightens that feedback loop and allows the developer to be empowered to actually correct it themselves, right? They're going to not only have this investment in the code quality, but also the understanding the developers have. Again, it's also important to make sure that the tools you use integrate properly with your version control system and the other tools that you have. So being able to create issues, create comments, create tickets is something that you want to make sure this whole ecosystem plays nice together. And again, we want to flag this within the context of the developer's workflow. So within the version control system, it's important that your solution shows these issues where the developers are comfortable working today, right? So if you see here, Codacy as an example, will comment those issues on GitHub or Bitbucket or GitLab. And that way the developer will understand, okay, here's that issue. It's blocked my PR here. Here's how I can go in, click, and it will show me how to fix it. That said, there's always 2 halves to code quality, right? There's the changes that you're going to be making, which might have a detrimental impact to code quality. And then there's also the component which ties into the existing technical debt. What's accrued over the years where we were just doing those manual reviews. And a good example of that is what PayPal has here with the Issues tab. Our Issues tab will show me all the different issues I have, in this case 83, and I can filter that based on the languages, the categories, the levels of severity, the patterns themselves, and the author. So if I'm a manager and I want to see what my team is struggling with, I can filter there. Or a great use case is exactly what PayPal's done. I can filter by the categories, I can go to security, and I can see that PayPal has addressed all security issues that would be more severe than a warning. And if they wanted to address the 2 remaining security issues they have in this project, they know exactly what they are. In this case, it's potential path transversal on line 137 and 155 respectively. We know who introduced it. In this case, it was a couple of years ago, so we still have that flagged. We know how to fix it. And we know that we need to allocate approximately 40 minutes across these 2 issues to get that addressed. So this is what's making that actionable and a way for you to report on the issues that you have, right? You have these stakeholders in security. Being able to demonstrate what you have and levels of severity is a key component to any static analysis tool. Next, I'm going to highlight really what goes into powering the analysis. And these are the code patterns. So when you add a project to Codacy, we're going to automatically detect the languages you're using, even if you have multiple languages in that project, and apply the appropriate linters, right? From there, you can go through and you can select the different patterns that you want to have enabled by simply checking these boxes. And oftentimes you can go through and customize the parameters, right? If you're already using some linters, but you want to move away from managing those yourselves and you want to do it more at scale, you can oftentimes add a configuration file as well. That way you're going to be able to standardize, once again, across all of these projects, making sure that you're going to be checking for these patterns. In mass, Codacy supports almost 30 different languages and 6,000 different patterns, right? So just understanding what that looks like, we understand it would be impossible for an individual developer to review for all of that at scale, which is what the benefits of an automated code review platform would be. These are also the other linters that go into Codacy, right? So the only reason I highlight this is we understand that if you were to have a team tasked with maintaining these linters themselves, it would be a full-time job. And that would tie into the problem of creating another problem, trying to solve something. So that's where undifferentiated heavy lifting comes into play. For the settings, I want to flag what those integrations would look like. Once again, we want to make sure that our tool is reporting this information where developers are comfortable. So be it in GitHub or Slack or Jira. And then lastly, what does that governance look like, right? Being able to flag what these commits and these pull requests are. By increasing these issues, we can be more lenient. By decreasing, we can be more strict, right? A negative number would require a fix. And this way we can get this hold and this quality gate on those quality changes and the trends these issues would have. It also allows us to customize per project what our goals would be, right? What are we going to define as an issue percentage would be? What are we going to define complexity as? And this way we understand that every company isn't going to be the same, and certainly every project within each company is not going to be the same. So being able to configure and customize this to fit your needs is a key component of that. So that's really just a high-level view and a condensed version of walking through what a static analysis platform to automate code review looks like. Certainly encourage the team to, or individuals here to explore that further.